So this is the second video for this week. If you have not watched the first video on picking a strategy to solve a quadratic equation, please stop this video to go watch that one first. If you've already watched the first video, you are now ready for the second concept we're going to talk about this week. This video is going to go over something that we have actually talked about before in a different situation, and now we're going to really focus on solving. What we're going to do today is we are going to focus on how you can solve a system of equations. Now, solving a system of equations is actually something we have done before. We've analyzed systems. We're specifically now going to focus on solving systems. Now, before we get started on exactly what that looks like, we need to review what a system is. What is a system of equations? Well, a system of equations just means a set of equations that are happening all at the same time. And by set, we mean more than one. In our case this week, we're going to focus on a system that has two equations. One of those equations is going to be a linear equation. As you remember, that means it's a straight line with a positive or negative slope. And the other equation we're going to focus on is a quadratic equation, which is that parabola that opens up or down. Now, if we have these two equations happening at the same time, that means we're going to put both equations on the same graph. So let's say that I have a linear equation that I'm going to put in green. So here is my linear equation. On the graph, it would look like that. But I might also have a quadratic equation. I'm going to put that as my orange graph. You'll notice that this system is on the same graph because these equations are happening at the same time. What's interesting when you solve a system is now you're not just looking at the properties of the graph, but you're specifically focusing on where do these graphs cross, or where do they meet? Because when you solve a system, you're essentially finding the x values that make the equations equal. So when my graphs cross, whatever that x value was that I input, that told me the y value for both my linear function and my quadratic function is the same. So when you're solving a system, you're just finding the x values that make the equations equal or the same. Essentially, that means where do they cross on the graph? So if I was able to graph my system, I could find where they cross and look at that x value. We're going to learn how you can solve a solution for a system of equations without graphing, but by using some of the strategies we've talked about. Now, we do like to give you some helpful tips and steps in a process that make this a little bit easier. So we would highly recommend that you write this down because we're going to share 3 steps with you that will help you solve a system where one of the equations is linear and the other equation is a quadratic. Now, you can actually use these 3 steps with any system, but particularly we're looking at a linear and quadratic this week. So the first step in our steps is we're going to take each of our equations and we're going to set them equal to each other. We want them to be equal because we're looking for when those graphs are the same, when their y values are the same. So we're going to set them equal to one another. Now, one of those equations is going to be a quadratic. What we know about quadratics is in many of our strategies, we like the equation to be equal to 0. So we're actually going to get one side of our new equation that we've built to be equal to 0. Now that might mean we have to do some eliminating using inverse operations. Once my equation is equal to 0, then I can solve it using any of the strategies we've talked about. So if you want to take a second to write these 3 steps down, it could be helpful as you go through the practice and the graded assignment this week. One of the things that you'll notice is that we're solving just like normal. This last step just says solve. You're going to find what x equals. What does that mean? Well, you found 1 or 2 solutions. And those represent the x values where the y values for both equation is the same. This essentially is where they cross. Where do these graphs cross? And what x value is that? So let's look and see what this would look like. All right, we're going to start with this system. The system that we're looking at has a linear equation and a quadratic equation. We have f of x equals x minus 2 and g of x equals x squared plus 2x minus 8. So I want to figure out where these two functions cross on the coordinate plane. So the first thing I'm going to do is follow my first step, which says set the equations equal to each other. So I'm going to take my first equation, x minus 2, and set it equal to the other equation, x squared plus 2x minus 8. I want my equations to meet, to cross. So by setting them equal to each other, I'm saying that I'm trying to find what x is when y is the same. So I did my first step. Now the second step says we need to get one side equal to 0. Well, I noticed that the left side only has 2 terms on it, and the right side has 3 terms on it. So it'd be easier to get rid of these two because it'll be less steps. So we're going to try and get this side equal to 0 by using inverse operations. I'm going to get rid of this x first by minusing it, inverse operation. Whatever I do on one side, I have to do to the other. Lining up with my same like terms. That cancels here, and I'm left with negative 2 equals x squared plus 2x minus x just leaves me with 1x, and then I still have minus 8. So I'm close to getting to 0. Let's do it one more time. I have a negative 2 I have to get rid of, so we'll do inverse plus 2. Whatever I do on one side, I have to do to the other. That cancels and leaves me with 0 equals x squared plus x. Negative 8 plus 2 is minus 6. All right. So I did my second step. Now it's equal to 0. Here's where the first video is talking about picking a strategy is going to come in handy. I notice here that I have a standard form equation. What we know is that the most efficient strategy for standard form equation is the quadratic formula. But if you listen to the last video, it's not my favorite strategy to use. So I actually want to try and convert this to factored form. I personally like solving by factoring, so I want to get this into factored form. So I'm going to convert using my T-bar strategy to get this into factored form. I'm looking for two numbers that multiply to my C value, negative 6, and add to my B value of 1. Okay, two numbers that multiply to negative 6 and add to 1. Oh, I could do a positive 3 and a negative 2. Positive 3 times negative 2 is negative 6, but 3 plus negative 2 equals 1. So I found my two factors that I can now go write in factored form. I could rewrite this as 0 equals x plus 3 times x minus 2. So I took my two factors and I plugged it into factored form. Now that I'm in factored form, which I like, I can solve by factoring. To me, that's a pretty quick strategy to use. So I'm going to set my first set of parentheses equal to 0 and my second set of parentheses equal to 0. And now I can just solve for x. Minus 3 from both sides cancels. X equals negative 3. My other one, plus 2 cancels. X equals 2. So I found the solution to my system. When x is negative 3 or when x is 2, these two equations will cross. I want to show you what this looks like on a graph. We're going to take a look. I plugged these two equations in as a system on my Desmos, and I noticed here that my blue equation represents my quadratic, my parabola, and my green equation represents my linear x minus 2. I notice that it crosses at this point, which on the x-axis is -3, and it crosses at this point, which is at the x-axis too. So the x values where they cross are -3 and 2. If I check my work, I notice that I found my answers to be -3 and 2. So I know I did this correctly. Great. Let's try one more. The second system we're going to look at also has a quadratic equation, our h of x function, and a linear equation, our g of x function. All right, so I'm trying to solve this system. First step, I'm going to set my equations equal to each other. So that leaves me with x squared minus 6x plus 5 equals the other equation, x plus 5. Okay, great. I did my first step. I set them equal to each other. Now my second step is to get one side equal to 0. The left side has 3 terms. The right side has 2. So I want to get rid of the right side because there's less terms. We're going to minus our x from both sides. That leaves me with x squared minus 6x minus another x is minus 7x. Still have my plus 5 equals 5. Okay, getting closer. I want to get rid of that 5, so I'm going to do the inverse operation, minus 5 minus 5. That leaves me with x squared minus 7x. That canceled equals 0. Great. So now I have my one side equal to 0. So now I can do the next and final step, which is solve for x using any strategy. Now this is strange though, because this doesn't look to me like any of my forms. I don't see parentheses, which would hint to me it's vertex form. I don't see 2 sets of parentheses, which would hint to me it's factored form, which would mean it's standard, but I feel like I'm missing something. Hopefully you noticed this actually is standard form. There is a secret A value here. There's a B value, and even though there's no C value, there's technically a secret C value there as well. So I actually want to use my, I know that this is in standard form. There's just some hidden numbers there. Now in the last example, I had standard form and I converted it to factored form. In this one, I'm going to stick with standard form and I'm going to solve using the quadratic formula. I'm going to use the strategy that the equation's giving me. So if we remember back to last week, we know that the quadratic formula tells us we need to find our A value, our B value, and our C value in order to plug in. So let's see if we can figure out what these are. My A value looks like it's not there, but it's secretly there, which is the number 1. My B value is -7. And my C value, even though it looks like it's not there, it really is because it's technically the value of 0. No C value means there is no C, which is just the value of 0. So now I have my A, my B, and my C. I'm going to plug this into my quadratic formula, which we learned last week was x, I'm going to do my song again, ready? X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now we have our formula that we can plug everything into. Okay, here we go. X equals -b, which is -7, plus or minus the square root of b, -7 squared, minus 4 times a, which is 1, times c, which is 0, all divided by 2 times a, which is 1. All right, let's go back to our steps. We're going to start simplifying. -7, I'm going to kind of move my equation over here. -7 just means +7, plus or minus the square root of -7 squared is 49. -4 times 1 is -4. -4 times 0 is 0. So actually, this is just plus 0. over 2 times 1 is 2. So I'm going to simplify 49 plus 0, 7 plus or minus the square root of just 49 divided by 2. All right, I simplified as much as I can. Now because I'm ready to just square root this here, that's my last step. I know I'm ready to break off into my 2 equations. What is the square root of 49? There's 2 choices. The square root of 49 is either 7 or negative 7. So I would do 7 plus the square root of 49 is 7 divided by 2, or 7 minus 7 over 2. Again, the square root of 49 is either plus 7 or minus 7. So I just plugged those in. And now I'm ready to simplify and solve. 7 plus 7 is 14 divided by 2. 14 divided by 2 is 7. So x equals 7. Try the second equation. 7 minus 7 is 0 divided by 2. 0 divided by 2 is just 0. So x equals 0. So I know that when x is 7 or x is 0, my 2 equations in my system would be crossing on my graph. Let's go check it out and see if I did that correctly. Again, we're looking to see that x is 7 and x is 0 when they cross. So let's head back to our Desmos. If I can get it back up there again. Okay. Here we go. Now these are the equations I did last time. So I'm going to enter my new equations in here. I had x squared minus 6x plus 5. And my second equation was x plus 5. Okay, let's take a look at where they cross. I'm going to zoom out a little bit. Okay, here we go. I see that they cross right here. What's that x value? 0. I also see they cross right here. Right at this point, what's that x value? 7. So I see they cross at 0 and 7. Okay, let's go back to see our work. See how we did. We had 7 and 0. So we did find the correct answers. So again, anytime you're solving a system, you're starting by setting the equations equal to each other. Then you're doing some algebra to get the equation equal to 0, and then you're picking a strategy to solve. Again, whatever strategy works for you, either the one that matches the form of the equation, or you can convert like I did on my first example. So this week, we're practicing picking strategies to solve equations and solving systems of equations using any of the strategies that you've been given. All of the algebra teachers are highly recommending that you do practice before you take the graded assignment. Even doing one practice each week will give you the background you need to make sure that you can reflect on any errors that you might be having before you move forward. We'd also love to see some more people attend our office hours, or our check-in hours as we're calling them now. We are available to go through examples, answer questions. So we would really love for you to join us on Tuesday and Thursday at 12:45 to 1:30. You can join at any time during those calls, and we'll be there to help you out when you need. Great job this week. Good luck, and let us know if you have any questions.